The word for the number 4 has 4 letters. It is the only number in the English language that has the same number of letters as its value, and that's not really a mathematics fact, but we can make it a bit more mathsy because you can consider this a function that takes a number, turns it into its word in English, and then counts how many letters that word has. And for that function, 4 is a fixed point. It doesn't go anywhere, it maps to itself. So you can consider this like a sequence. If you start with 8, well, that's got 5 letters, so we map to 5. That's got 4 letters, we map to 4. There we are. And 4 maps to itself. We stay there. You can start with any number. If you repeat this process, you will always end up trapped at 4. I'm quite jealous of other languages that have more interesting structures in their networks for the letter counting function. So Indonesian, of all languages, the Indonesian word for 4 is empat. And you go, well, hang on, that's got 5 letters, but the Indonesian word for 5, lima, has 4 letters. And so you get this nice little 2 cycle. And all Indonesian words feed into this 2 cycle. French is even better. So the word for 3 in French, trois, that has got 5 letters. The word for 5 has got 4 letters. The word for 4 has got 6 letters. The word for 6, which is spelt the same as English, has 3 letters, and we're back where we started. All French words for numbers end up in this full cycle here. It's absolutely fantastic. It's only a shame that I can't pronounce these words for you correctly in French. You see, I can't speak French. Traditionally, I let the funky music do the talking. Talking now. So back to boring English with its sinkhole at 4. But how do we know that that fixed point is the only real structure in the network? How do we know there's not a cycle somewhere else? Well, for there to be a cycle somewhere, you need to have words which contain more letters than the value of that number. And that only occurs in English for numbers smaller than 4. All of 1, 2, and 3 do have more letters than their value, but above 4, 5 onwards all have fewer letters. You can see 4 is a kind of threshold where above it every single number has fewer letters than its value, and so everything must drift down to this point. The same thing happens in French, Indonesian, and other languages, and while I'm not completely sure about this, I have a conjecture. And my conjecture is for any linguistic number system, there is some threshold k such that for all numbers bigger than k, they have more letters than the number they represent. And as a kind of, I guess, sub-conjecture, I suspect that generally speaking, k is quite small. I'm ruling out trivial things like a tally. Yeah, 4 could be dash, 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 but you're just multiplying up the value of the number by how many letters are in whatever you're calling the line in your tally. And that would give you a geometric sequence, which, while wonderful and interesting, is not what I'm after here. Fun fact, the highest k value I have found for any linguistic number system is 18, and that's for just reading it out in binary. 18 is 10010, and that has 18 letters. Anything above 18, reading out in binary, you've got fewer letters than the value of that number, and so you get this fixed point at 18. There's actually another fixed point at 13 because 1101 has 13 letters, and so all numbers in this system will hit one of those 2 points. They actually hit 18 a lot more than 13. For smaller numbers, it's not so bad. If you do all the numbers up to 100, 16 of them end at 13 and the remaining 84 end up at 18. But as you get bigger, the vast majority hit 18 before they have any chance to get anywhere near 13. Were you to write a program to check all the numbers up to 1,000,000, which I may have done, you will find that 99.9904% of them hit 18 and the remaining 0.0096% of them hit 13. Please do double check I got that right. If we don't have any loops in English, can we still have some fun? Well, yes. The first option is to cheat. Nine's got 4 letters, but let's swap that out to be niner. There we are, 5 letters now, and 5 could be fiverino. That's 9 letters. That's not going to work, is it? Plan B, we have some near misses. So 50 has 5 letters and it's 10 times 5 and we're in base 10. That's kind of nice. Likewise, 70 has 7 letters, which means you get the kind of quirky things like 54 is a 5 and a 4 if you look at the letters of the 2 words, and 74, 7 and 4. But, you know, it's not quite as satisfying. It's kind of a function where you split up all of the words, count the letters, and then use them in the columns of the base. I mean, come on. When this all occurred to me yesterday, I started playing around with it and realized just how boring the English language can be. I realize there's only one real option for what to do here. If we accept that everything is going to end up at 4, we can try and find the longest chain of numbers that ends up at 4. And so first of all, I checked all the chains for numbers below 100, and there are several chains in there which are 6 numbers long. And so I picked the one with the smallest starting number. I've got it here. So if you start at 23, 23 has 11 letters, 11 has 6 letters, 6 has 3 letters, which has 5 letters, which gives us 4. I did find some 7 chains when I checked all the way up to 1,000,000. There are quite a few of them, and so I now know the smallest 7 chain that ends up at 4, but I'm not going to tell you what that is. That's partly so you find people can try and find it yourself, and partly because it depends on how you say words above 100. So you've got an option. So for something like 496, that can be 496 or just 496. I went with 496. Other options are available. That's my short introduction to the letter counting function. You've now got 3 optional pieces of homework. You can try and find a longer chain. I've found them up to 7. I have no doubt there are bigger ones. As long as you state your naming conventions, I don't mind what you use as long as it's logical and semi-consistent. Or number 2, you can try and find a language which has got a bigger loop than French. To be fair, I haven't checked very many. French has a loop with 4 numbers in it. See if you can locate a language with more than 4 in a cycle. And thirdly, your last bit of homework, can you find or come up with some kind of linguistic number system which has a K threshold of greater than 18? A bonus challenge, I guess, is to find things like 3 times square root 100, which does indeed equal 30 and has 30 letters, but things like that, they're kind of medium pleasing. Obviously, doing the maths is its own reward, but for a literal, less figurative reward, I'm going to take my cheat notes here of my 6 cycle. I'm going to sign them down the bottom, and I will pick whichever answer in the comments to this video I think is the most pleasing, and they can win this. I'll write congratulations in your name and I'll post that to you. I've not got a huge amount of free time at the moment. I'm meant to be writing a book. I've got a looming first draft deadline coming up. So if you see someone else put any kind of finding in the comments, I would hugely appreciate it if you can double check it for me. If you already know the language they're using, or you can work out what they're trying to do and you see it works or it doesn't, please leave a comment underneath to let me know. And if you see someone's suggestion or someone's finding and you think, that is really good, do leave a comment. Say, hey, I think this is the person who should win the prize. And that will help me immensely to whittle it down to a few good entries, one of which will get this. So I don't know why you're still watching this. Get to work.